Hello and welcome to Lucid Mind Chemistry channel with Majid. In this video, I'll be solving Chemistry A-Levels Multiple Choice Paper 13 from May-June 2019. You can go to any particular question by following timestamps given in the video description. Let's start. Question 1. Manganese and nitrogen can show a range of different oxidation states. Calculate the sum of the oxidation states of Mn and nitrogen in each row of the table. In which row is the sum the smallest? These are the compounds containing manganese and these are the compounds containing nitrogen. Let's first find out the oxidation state of manganese in these compounds. First one is MnCl4. Second is MnCO3. Then we have K2MnO4. And then we have MnOH3. In MnCl4 we have 1 manganese atom and 4 chlorine atoms and overall charge is 0. So as chlorine is from group 7 of the periodic table, its oxidation state is -1. So for 4 chlorine it will be -4. So Mn will be equal to +4. So it is +4 in MnCl4. Second is manganese carbonate. Now we know that we have 1 manganese and 1 carbonate. Overall charge is 0. So now the charge on carbonate is -2. So the charge on manganese should be +2. So it is +2 in this one. Third one is K2MnO4. We have 2 potassium, 1 Mn, 4 oxygen and overall charge is 0. Potassium is in group 1 of the periodic table, so its oxidation state is +1. So for 2 potassium it will be +2. Then we have manganese, then 4 oxygen. For 1 oxygen it is -2. So for 4 it will be -8. So Mn minus 6 equals 0. So Mn equals +6. In last one we have MnOH3. Now we know that we have 3 hydroxides and overall charge is 0. The charge on 1 hydroxide is -1. So for 3 it will be -3. So Mn equals +3. So the oxidation state is +3 in MnOH3. Second we have nitrogen. As nitrogen is a molecule, so the oxidation state will be 0. And then we have NO2 negative. Then NH4 positive and NH2OH. In the first one we have 1 nitrogen, 2 oxygens and overall charge is -1. So 1 nitrogen minus 4 equals -1. So nitrogen equals +3. So it is +3 in NO2. In second one we have ammonium ion, 1 nitrogen, 4 hydrogens and overall charge is +1. As nitrogen is more electronegative, so the charge on hydrogen will be positive. So it is +4. So now nitrogen will be equal to -3. Similarly, in the last one we have 1 nitrogen, 3 hydrogen atoms, 1 oxygen atom and overall charge is 0. So nitrogen +3 minus 2 equals 0. Nitrogen +1 equals 0 or nitrogen equals -1. So the oxidation state of nitrogen in the last one is -1. Now let's find the sum. The sum +4, 0 equals +4, +2 + 3 equals +5, +6 - 3 equals +3, +3 - 1 equals +2. So the least sum is in D, so therefore D is the answer. Question 2. The mass spectrum of an alloy of copper and gold is shown. On y-axis we have percentage abundance and on x-axis we have mass to charge ratio. Which expression can be used to calculate the relative atomic mass of copper present in the sample? Now from periodic table we know that this is the atomic masses of copper and this is the atomic mass of gold. Now we can find the relative atomic mass by using formula. Relative atomic mass is equal to percentage abundance of first isotope into its atomic mass plus percentage abundance of second isotope into its atomic mass and so on, divided by the sum of percent abundance values. Let's look into the options. In A, we can see that they have multiplied percent abundance into atomic mass of isotopes of copper, then divided by the percent abundance values. And they have also added the percent abundance of gold, which is wrong because we are not going to find the relative atomic mass of gold. We are just finding out the atomic mass of copper. So A is wrong. Similarly, in B, we can see that they have added the percent abundance of gold, and also they have multiplied with the percent abundance and atomic mass of gold, which is wrong. In C, they have multiplied the percent abundance with atomic masses of both the isotopes of copper, then divided by the sum of percent abundance value. So C is the correct option. In D, again we can see that they have multiplied percent abundance values with atomic masses of both isotopes of copper divided by the sum of masses, which is wrong. So D is incorrect. Also, by finding out the calculation, we come to conclusion that the value for C is equal to 63.61. Now this is in between 63 and 65, so it means that this value is correct. The answer is therefore C. Question 3. Which atom has exactly 3 unpaired electrons? In A, we have isolated gaseous aluminum atom. The atomic number of aluminum is 13, so there must be 13 electrons in aluminum atom. For carbon, the atomic number is 6, so we have 6 electrons. Similarly, for chromium, the atomic number is 24, so we have 24 electrons, and for phosphorus, the number of electrons is 50. Let's do electronic configuration. First for aluminum atom. So aluminum equals 1s2, 2s2, 2p6, 3s2, and in 3p we just have 1 electron left. So we just have 1 unpaired electron, so therefore A is incorrect. Similarly for carbon, we can do the electronic configuration 1s2, 2s2, and in 2p we have 2px and 2py. So the number of electrons is 1 in each 2px and 2py, so we have 2 unpaired electrons. Actually we need 3 unpaired electrons, so carbon is also incorrect. Now for chromium atom, we can do the electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 3d and 4s. Now as we know that 3d is more stable when it has half filled electrons, which is equal to 5. So it must be 3d 5 and 4s 1. Now 3d subshell consists of 5 different orbitals. First is 3d xy, then we have 3d yz, then xz, then x square y square, and then z square. This is the orientation of 3d orbitals on x and y axis. Now putting electrons in these orbitals, we have 5 electrons, so there must be 5 unpaired electrons present in d orbitals. And as we need 3 unpaired electrons, so therefore C is also incorrect. Last one is phosphorus. For phosphorus, the electronic configuration will be 1s2, 2s2, 2p6, 3s2. And in 3p we have 3 orbitals, 3px, 3py and 3pz. As 3 electrons are left, so 1 electron will come in each orbital. So now we have 3 unpaired electrons, so therefore D is correct. Correct answer is therefore D. Question 4. Element W is in period 3 of the periodic table and has a solid white oxide X. X is thermally stable and has a very high melting point. X is slightly soluble in water. Which row describes the structure and bonding of X? Now in period 3 we have sodium, magnesium, aluminum, silicon, phosphorus, sulfur and chlorine. Now in the question they have given that X forms solid white oxide which has very high melting point. So it means it is not phosphorus oxide, sulfur oxide, and chlorine does not form any oxides. Then we have aluminum oxide and silicon dioxide which are insoluble in water. While X is slightly soluble in water, it means it is not aluminum or silicon. So now we have sodium and magnesium left. Both sodium and magnesium are metals. So with oxygen they form ionic bond, so it must be ionic bond. And in ionic bond, positive ions and negative ions are present in giant three-dimensional lattice. There are no small molecules present. The answer is therefore C. Question 5. Ethane CH3CH3 and fluoromethane CH3F have the same number of electrons in their molecules. Their boiling points are given. The boiling point of CH3CH3 is less than CH3F. What is responsible for this difference in boiling points? Now we know that boiling point is always dependent on strong intermolecular forces of attraction. A. CH3F has a larger MR than CH3CH3. The molecular mass of CH3F equals 34 while that of CH3CH3 equals 30. As we can see that the molecular mass of CH3F is greater than CH3CH3, so this statement is true. But we cannot judge the boiling points on the basis of these molecular masses as the compounds given are different. So A is incorrect. B. CH3F has a permanent dipole, CH3CH3 does not. Now we know that the electronegativity difference between carbon and hydrogen is not much, so therefore CH3CH3 is non-polar compound, while fluorine is the most electronegative element present in the periodic table, so it must have a partial negative and partial positive charges. So a permanent dipole is present in CH3F and it is absent in CH3CH3. So therefore it could be the reason for high boiling point. C. CH3F has a strong carbon-fluorine bond, CH3CH3 does not. Now this part is true because carbon-fluorine bond is very difficult to break, but what happens in boiling point is that we do not break any bonds, only the intermolecular forces are overcome, so therefore C is wrong. D. Hydrogen bonding occurs in CH3F but not in CH3CH3. In CH3F we can see that hydrogen is bonded to carbon atom, while carbon is bonded to fluorine atom. So hydrogen bonding cannot take place, as for hydrogen bonding, one of the hydrogen atom must be bonded to either fluorine, oxygen or nitrogen directly. As there is no direct bond between fluorine and hydrogen, so therefore there is no hydrogen bonding in CH3F and there is also no hydrogen bonding in CH3CH3. So D is incorrect. Correct answer is therefore B. Question 6. The reaction pathway diagram for chemical reaction is shown. On y-axis we have energy, on an x-axis we have progress of reaction. This is the reactant line and this is the product energy line. Which statement is correct? A. The activation energy of the forward reaction and the enthalpy change of the backward reaction have the same sign. Let's find out the activation energy for the forward reaction. Activation energy is the energy that is required by the reactants to reach the transition state. So this is activation energy and it is positive. Now the enthalpy change of backward reaction is the energy difference between the reactants and products. So the enthalpy change for backward reaction is negative as we are moving from high energy state to low energy state. So therefore they do not have same sign. So A is wrong. Part B, the activation energy of the forward reaction is more than twice the enthalpy change of the backward reaction and opposite in sign. Again, the activation energy of the forward reaction is positive while the enthalpy change of the backward reaction is negative. So it is opposite in sign. Now let's find out whether it is more than twice or not. As we can see that the activation energy of the forward reaction consists of 1, 2, 3, 4 lines, while the enthalpy change of the backward reaction consists of 2 lines. So it is exactly half of the forward reaction, so therefore we can say that it is not more than twice, it is exactly twice the enthalpy change. So B is incorrect. Part C, the enthalpy change of the forward reaction and the activation energy of the backward reaction have the same sign. Now the enthalpy change of the forward reaction is the energy difference between the reactants and products. It is positive, as energy is absorbed from low energy to high energy. Now the activation energy of the backward reaction is also positive, because activation energy is the amount of energy that is required by these reactants to convert into this product. So C could be true. Part D, the enthalpy change of the forward reaction is more than twice the activation energy of the backward reaction. Now the enthalpy change of forward reaction is consisting of these two lines, while the activation energy of the backward reaction also consists of two lines, so these are actually equal. So it is not more than twice, so therefore it is incorrect. Correct answer is therefore C. Question 7. What changes in conditions or molecular properties make it more likely that gases approach ideal behavior? Now for ideal gas, you must remember that there are zero forces of attraction or repulsion between the molecules, and there are large spaces between the molecules. In A, we have higher pressure, so at higher pressure the spaces will become smaller. So it is incorrect. B, at lower temperature the intermolecular forces will develop, so it is also incorrect. C, more polar molecules means more intermolecular forces of attraction, so it is also incorrect. D is weaker intermolecular forces. So as we are approaching zero forces for ideal behavior, so there must be weaker intermolecular forces present. The correct answer is therefore D. Question 8. Ethanol can be oxidized to ethanol by dilute acidified dichromate 6 ions. The oxidation reaction equation is this one. The reduction reaction equation is this one. Which equation is correct? As we can see that in oxidation 2 electrons are lost, while in reduction 6 electrons are gained. So in order to balance these equations, the number of electrons lost must be equal to the number of electrons gained. So we can multiply the first equation by 3 to make it 6 electrons. So first equation will become 3C2H5OH, 3C2H4O, 6 H positive and 6 electrons. Now combining both second and third equation, we can write Cr2O7 -2 plus, on the reactant side we had 14 H positive, on the product side we had 6, so 14 minus 6 becomes 8 H positive on the reactant side. Then we have 3 C2H5OH molecules, and on the product side we have 2 Cr plus 3, 7 H2O, and these 6 electrons are cancelled out with these 6 electrons, and there is no H positive ion left as 6 were cancelled with 14. And now we have 3 C2H4O present, so we can write 3 C2H4O. Now this is the balanced equation, and we can see from given option that this corresponds to option A. Question 9. What is the correct expression for Kc, which is equilibrium constant expression for the reaction shown? We have 1 mole of iodine that reacts with 2 moles of iron plus 2 to form 2 mole of iodide and 2 moles of iron plus 3. Let's write Kc. Kc is equal to the concentration of product. The first product is I negative. For concentration we use square brackets. Raised to the power is number of moles. As it has 2 moles, so it will be power 2. multiply by second product, which is iron plus 3, its concentration, raised to the power its number of moles, which is 2, divided by the concentration of reactants. First is iodine, so its concentration raised to the power its number of moles, which is 1, multiply by second reactant, which is iron plus 2, raised to the power its number of moles, which is 2. So among the given options, we can see that B fits the given description. Question number 10. X and Y react together to form Z in a reversible reaction. The equilibrium yield of Z is lower at higher temperature. The equilibrium yield of Z is lower at lower pressure. Which equation could represent this reaction? As we can see that Z is the product and X and Y are the reactants in this equilibrium. Now at higher temperature, the concentration or equilibrium yield of Z becomes lower. It means that the reaction is exothermic. This is because for exothermic reaction, the temperature is the product. So if you are increasing the temperature, the equilibrium will move in the backward direction. So product will become low. So it should be either negative 100 or this one, as both are exothermic. Now moving towards the second option, the equilibrium yield of Z is lower at lower pressure. As we know that higher pressure makes the equilibrium go from more number of moles to less number of moles, while lower pressure will make the equilibrium move from less number of moles to more number of moles. Let's find out the number of moles. We have 1 plus 1, so 2 moles of reactant and 1 mole of product. So this reaction can go from less number of moles to more number of moles. So A could be correct. In C, we can see that we have 2 number of moles of reactants and 2 number of moles of product. So as the number of moles are equal, so there will be no effect of pressure on the equilibrium yield. So C is incorrect. Correct answer is therefore A. Question 11. The volume of carbon dioxide collected by reacting 0.1 mole of magnesium carbonate with 50 cm3 of 1 mole per decimeter cube sulfuric acid is measured against time. The volume produced is plotted against time and the line labeled P on the graph is obtained. As we can see that Q have higher volume of carbon dioxide and P has lower volume of CO2 produced. The experiment is repeated using 0.1 mole of the same magnesium carbonate and a different sample of acid. All other conditions remain the same. Plotting these results give the line labeled Q. Which sample of acid could give the line labeled Q? So P is obtained from this reaction of 0.1 mole magnesium carbonate with 50 cm3 of 1 mole per decimeter cube sulfuric acid, while Q is obtained by using different sample of acid. Let's find the number of moles by using the formula. Number of moles is equal to concentration in mole per decimeter cube into volume in decimeter cube. Concentration is 1 mole per decimeter cube and volume is 50 centimeter cube, so we can convert it into decimeter cube by dividing by 1000. So the number of moles of sulfuric acid present are 0.05 moles. Let's write the balanced equation between magnesium carbonate and sulfuric acid so we can come to know how many moles of reactant and products are involved. So H2SO4 plus magnesium carbonate, it forms magnesium sulfate along with water and carbon dioxide. As we can see that this equation is already balanced, so we have equal number of moles of reactant that react together. So we had 0.1 mole of magnesium carbonate and we had 0.05 moles of sulfuric acid. So the reaction is incomplete because magnesium carbonate has left behind. Now we can increase the volume of carbon dioxide by increasing the number of moles of sulfuric acid. So let's look into the options. In A, we have 100 centimeter cube of 0.5 mole per decimeter cube sulfuric acid. So using the formula number of moles into concentration into volume in decimeter cube, the number of moles come equal to 0.05 moles. Now these number of moles are same as the one given in the question. So therefore the volume of carbon dioxide will not be changed, it will still be P. So A is incorrect. Similarly, using the formula for second concentration, we have 100 centimeter cube of 1 mole per decimeter cube sulfuric acid. So the number of moles come equal to 0.1 moles. Now we can see that number of moles has increased. So if number of moles has increased, the volume of carbon dioxide will also increase. So this one seems to be correct. Now looking at the second thing, which is the rate of chemical reaction, as we can see that the rate of reaction for P is higher as it is more steep, and the rate of reaction of Q is less as it is less steep. As the rate of chemical reaction depends on the concentration of the reactants, and we have sulfuric acid as one of the reactants, so now we can see that the concentration is 1 mole per decimeter cube given in the question, and we also have 1 mole per decimeter cube given in part B. So the rate of reaction should be same, it should not be less as the concentration is same. So therefore B is incorrect for rate of chemical reaction. Moving towards part C, we have 200 centimeter cube of 0.5 mole per decimeter cube hydrochloric acid. Now the acid has changed, so therefore the balanced equation will also change. Let's write the balanced equation of magnesium carbonate with HCl. So we can write MgCO3 plus HCl. It forms magnesium chloride, water and carbon dioxide. Let's balance this chemical equation. The number of magnesium atoms is equal on both sides. We have 2 hydrogen atoms and 2 chlorine atoms in the product, so we can write 2 with HCl. Rest of the equation is already balanced. So we can say that for complete reaction, 1 mole of magnesium carbonate requires 2 moles of HCl. So as we can see that the number of moles of magnesium carbonate given is 0.1 moles. So it means for 0.1 mole of magnesium carbonate for complete reaction, we must have 0.2 moles of HCl. Let's find the number of moles of HCl in part C. Using formula N is equal to C into V, the number of moles of C comes equal to 0.1 moles. Now as we can see that 0.1 mole of HCl are produced instead of 0.2 moles, so therefore volume of carbon dioxide will still be less. So C is incorrect. Now number of moles in part D equals 0.2 moles. Now as we can see that 0.2 moles are required for complete reaction of magnesium carbonate. So when magnesium carbonate has reacted completely, then volume of carbon dioxide will be higher. So it could be Q. Now comparing the concentration, we can see that the concentration of hydrochloric acid is 1 mole per decimeter cube, while in the first reaction of P, the concentration of sulfuric acid was also 1 mole per decimeter cube. So now as we can see that 1 mole of sulfuric acid produces 2 moles of H positive ions, while 1 mole of HCl produces 1 mole of H positive ions in a balanced chemical equation. So as in HCl, the number of moles of H positive ions are less, so therefore the rate of reaction will also be less. So therefore we can see that HCl produces more volume of carbon dioxide as it has more number of moles, and the rate of reaction is lower as the number of moles of H positive ions formed is less. So both are true for D. The answer is therefore D. Question 12. Sodium and sulfur react together to form sodium sulfide. How do the atomic radius and ionic radius of sodium compare with those of sulfur? As we can see that sodium and sulfur are present in the same period. So we have sodium, magnesium, aluminum, silicon, phosphorus and sulfur. The atomic number of sodium is 11, for magnesium it is 12, then 13, 14 and 15, 16. As in the same period, the number of shells remain constant, so therefore number of protons are increasing and number of electrons are increasing. So we can say that the electrostatic forces of attraction between nucleus and electrons increase, so therefore size will decrease. So the atomic radius of sulfur will be less than the atomic radius of sodium. So it could be either C or D. Now let's move towards ionic radius. Sodium is in group 1 of the periodic table and it will lose one electron to form Na+. The electronic configuration of sodium is 2, 8, 1, while for Na+ it is 2, 8, so there are only 2 shells left. While for sulfur, which is in group 6 of the periodic table, it will gain 2 electrons to form sulfur -2. The electronic configuration in the start was 2, 8, 6, while now it is 2, 8, 8. So as we can see that there are 3 shells in sulfide ion as compared to 2 shells in sodium ion. So therefore the ionic radius of sodium plus is less than sulfur -2. Correct answer is therefore D. Question 13. Which graph represents the variation in electronegativity for period 3 elements? Now you should remember that electronegativity is always directly proportional to atomic number or number of protons, and it is always inversely proportional to the size of atom. So as atomic number increases, the electronegativity increases. So we can see that sodium, magnesium, aluminum, silicon, phosphorus, sulfur and chlorine, the atomic number increases, so electronegativity should increase. And second is the size of atoms. So we know that in same period the size of atom always decreases, so it means the electronegativity will increase. Due to greater nuclear charge and greater number of electrons, the size of atom will be reduced. So B shows correct trend of electronegativity. Question 14. Dilute hydrochloric acid is added to solid barium carbonate and solid magnesium carbonate in separate test tubes. Dilute sodium hydroxide is added to 0.1 mole per decimeter cube barium chloride and 0.1 mole per decimeter cube magnesium chloride in separate test tubes. Which row is correct? First one is the reaction of barium carbonate with HCl. So the product will be barium chloride plus carbon dioxide gas plus water. So A is incorrect, it could be B, C or D. As carbon dioxide has been produced, so we can write effervescence is observed. The second reaction is of barium chloride with sodium hydroxide. The product will be barium hydroxide, which is soluble, plus sodium chloride, which is also aqueous soluble. So we can see no change as both are colorless solutions. For the third reaction of magnesium carbonate with HCl, again the product of carbonate with acid is salt, which is soluble, water and carbon dioxide. So again we can see effervescence is observed. In the last reaction of magnesium chloride with sodium hydroxide, the product will be magnesium hydroxide, which is precipitate as it is very less soluble. And second is sodium chloride, which is soluble. So there will be white precipitate of magnesium hydroxide present. The answer is therefore C. Question 15. River water in an agriculture area contains ammonium carbonate, hydrogen carbonate, chloride, nitrate ions. In a water treatment plant, this water is treated by adding a calculated quantity of calcium hydroxide. What is precipitated from the river water when calcium hydroxide is added? First one is calcium chloride. Now we know that calcium chloride is a soluble salt, so therefore it cannot be precipitated, so A is incorrect. B is calcium carbonate, which is insoluble salt, so it can be precipitated out. C is calcium nitrate, as we know that all nitrates are soluble. so C is also incorrect. D is ammonium hydroxide, which is also aqueous as it is soluble, so it will not be precipitated out. So only compound that can be precipitated is calcium carbonate. Question 16. The solids sodium chloride and sodium iodide both react with concentrated sulfuric acid at room temperature. With sodium chlorides, the products are sodium hydrogen sulfate and HCl. With sodium iodide, the products are sodium hydrogen sulfate, hydrogen iodide, iodine, sulfur dioxide, water, sulfur, and H2S. What is the explanation for this difference in products? As we can see that with sodium chloride, the oxidation state of chlorine is -1 in NaCl, and in the product we have HCl, the oxidation state is also -1. Now HCl is not further oxidized by sulfuric acid, while with sodium iodide we can see that the oxidation state of iodide is -1 in sodium iodide, while in iodine it is 0. So from -1 to 0 oxidation has taken place. You should remember that chloride ions are not oxidized by sulfuric acid. While iodide ions can be oxidized. So if iodide ions can be oxidized by sulfuric acid, it means iodide ions are better reducing agents than chloride ions. This is the only statement that can explain the difference in the products that are formed. Part A, chloride ions will displace iodine from solution. This has nothing to do with the difference in products, so therefore A is incorrect. In B, we can see that hydrogen chloride is more volatile than hydrogen iodide. This is a true statement, but again this has nothing to do with the difference in products formed. D is that sulfuric acid is able to act as a dehydrating agent with sodium iodide. Now dehydrating agent means removal of water, while in sodium iodide there is no water, so therefore statement D is also incorrect. Correct answer is therefore C. Question 17. An aqueous solution of calcium compound is treated with a mixture of dilute aqueous nitric acid and aqueous silver nitrate. The resulting white precipitate dissolves when dilute aqueous ammonia is added. What is the relative molecular mass of the calcium compound? Now we know that white precipitate that is formed by adding silver nitrate in a solution of calcium compound could be of silver chloride, which is white precipitate, and it is also soluble in dilute aqueous ammonia. This test is done for the presence of chloride ions, so it means that the calcium compound is calcium chloride. Let's find the molecular mass of calcium chloride. The atomic mass of calcium is 40, while for 1 chlorine it is 35.5. So it is 111.1. The answer is therefore C. Question 18. Which statement about the ammonium ion is correct? A. It can act as a Bronsted-Lowry base. Now this is incorrect because ammonium ion can donate H positive, so therefore it can act as Bronsted-Lowry acid. B. It can react with hydroxide ion to give ammonia. Now this is a true statement because ammonium salt can react with alkali aqueous to form ammonia and water. Again we can see that H positive ion has been donated to OH negative, so therefore this has acted as Bronsted-Lowry acid. and also ammonia is formed, so therefore B is correct. Part C, it is pyramidal with bond angles of 107 degrees. Now in ammonium ion there are 4 bonds, 3 covalent bond and 1 is coordinate covalent bond. So the structure is tetrahedral and bond angles is 109.5. So C is incorrect. D, the nitrogen atom is sp2 hybridized. As we can see that nitrogen is making 4 bonds, so it is not sp2, it is sp3 hybridized. One s orbital is involved and 3 p orbitals are involved to make 4 covalent bonds. So D is incorrect. Correct answer is therefore B. Question 19. In a catalytic converter, 5.6 grams of carbon monoxide reacts with an excess of nitrogen monoxide. What is produced in this reaction? We can write a balanced equation for the reaction. We have carbon monoxide that reacts with nitrogen monoxide to form carbon dioxide and nitrogen. We can balance this equation by writing 2 with nitrogen. Now we can balance carbon and oxygen by writing 2 with CO and 2 with CO2. As we can see that the ratio of moles of carbon monoxide and nitrogen monoxide is exactly same. Let's find out the number of moles present in 5.6 grams of carbon monoxide, as moles is equal to mass divided by molecular mass. Mass is 5.6 grams and MR of carbon monoxide is 16 plus 12, which is 28. So number of moles come equal to 0.2 moles. As we can see that 2 moles of carbon monoxide produces 2 moles of carbon dioxide and 1 mole of nitrogen. So therefore 0.2 moles of carbon monoxide will produce 0.2 moles of carbon dioxide and 0.1 moles of nitrogen. Let's convert these moles back into mass. So mass is equal to moles into MR. 0.2 into molecular mass of carbon dioxide, which is 44. So it comes equal to 8.8 grams. So it could be either C or D. Now for nitrogen, mass is equal to moles into molecular mass. Moles is 0.1 and molecular mass of N2 is 28. So it is 2.8 grams. The answer is therefore D. Question 20. The Finkelstein reaction occurs when sodium iodide in propanone reacts with chloroalkane or bromoalkane. The halogen is directly replaced by iodine. The reaction only works for primary halogenoalkanes. Which halogenoalkane produces compound X? This is the structure of compound X. We have 5 carbon atoms, 1 iodine is attached, 2 methyl groups are also present. As in the question, we can see that halogen is replaced by iodine, so therefore iodine would have replaced either chlorine or bromine from chloroalkane or bromoalkane. So the starting compound could be like this. It could be chlorine or bromine. We also have 2 methyl groups attached. We can write structure formula for this compound. We have CH3, then carbon hydrogen, this one. Then we have CH3 attached with this one. Again CH2. CH with methyl group, then again CH2 and then Cl or Br. Now we can also rewrite this formula. We have 2 CH3 with this CH, so we can write CH3 twice, CH, then CH2, then again CH. As this is the substituent, so we should put it in brackets, then CH2, then we have Cl or Br. As from given options we can see that D is similar to the compound that we have formed. Question 21. The diagram shows the skeletal formula of compound Y. What is the empirical formula of Y? Now empirical formula shows simplest ratio of atoms present. Let's find out the number of atoms. We have 1, 2, 3, 4 carbon atoms. Also we can see that this carbon is making 3 bonds, so there must be 1 hydrogen. This is also making 3 bonds, so there must be 1 hydrogen. So there are 1, 2, 3, 4 hydrogen atoms present. So we can write H4. Again we can see that we have 4 oxygen atoms that are present, so it is O4. So the empirical formula will be CHO. Correct answer is therefore A. Question 22. In polymer Z, every carbon atom in the polymer chain is bonded to 1 hydrogen atom and 1 methyl group. Which alkene could be polymerized to make polymer Z? Let's first draw the structure of polymer Z. It says that each carbon atom is bonded to 1 hydrogen atom and 1 methyl group. Similarly, this one is also bonded to 1 hydrogen atom and 1 methyl group, and so on. Let's first find out the repeat unit. So we should have at least 2 carbon atoms that are repeating itself. So we can see first and second carbon atoms are actually same. So the repeat unit will be like this. Now let's convert this repeat unit into monomer. We know that the side bonds are actually crossed and single bond between carbon atoms becomes double bond. So the monomer will be like this. Now let's find out the name of this monomer. We have 4 carbon atom containing double bond in the long chain. As double bond is present on second carbon atom, so it is but 2-ene. The answer is therefore B. Question 23. Which compound would produce a carboxylic acid and a ketone when treated with hot concentrated acidified manganate 7 ions? As we can see that in A, B, C and D we have alkene functional group that is present. For alkenes you should remember that when reacted with hot concentrated acidified manganate 7 ions, the double bond is broken and the products can be formed like this. If double bonded carbon is bonded to 2 hydrogen atom, then the product will be carbon dioxide upon oxidation. If the double bonded carbon is attached with one hydrogen atom and 1 alkyl group, it will be oxidized first to aldehyde and then further into carboxylic acid functional group. Again, if the double bonded carbon has 2 alkyl groups attached, so it will be oxidized into a ketone. Let's find out the products. In A, this is broken as we have 2 hydrogen atoms, so this will form CO2. And as on this carbon atom we have 1 hydrogen atom and 1 alkyl group is attached, so therefore this portion will form carboxylic acid. So no ketone is formed, so A is incorrect. In B we can see that this bond will break as this carbon atom has 1 hydrogen atom and this also has 1 hydrogen atom and 1 alkyl groups are present on both carbon atoms, so both will form carboxylic acid functional groups. So B is also incorrect as no ketone is formed. Similarly in C we can see that this double bond is broken and we have 2 alkyl group with this carbon atom and 2 alkyl groups are present with this carbon atom. So both these double bonded carbon will convert into ketone. So we have 2 different ketone products. So C is also incorrect as carboxylic acid is not produced. Now in D we can see that this double bond is broken and this carbon consists of 2 alkyl groups. So it will form ketone. And this second carbon, it consists of 1 hydrogen atom and 1 alkyl group. So it will form carboxylic acid. As both carboxylic acid and ketone are formed, so therefore D is correct. Question 24. Water is added to a sample of 2,3-dibromohexane. Some of 2,3-dibromohexane undergoes complete hydrolysis and some of it undergoes partial hydrolysis. What is not present in the mixture of products? Let's first draw the structure of 2,3-dibromohexane. We have 6 carbon atoms in the long chain. And on second carbon and on third carbon we have bromine atoms. Upon hydrolysis with water, what happens that OH from water will replace Br from compound. So now partial hydrolysis can take place and complete hydrolysis can also take place. So the product formed could be like this. Either this Br is changed with OH and this Br is not changed as it is partial hydrolysis. Or we can say that first Br is not changed while second one is converted into OH. If complete hydrolysis take place, then both Br will be converted into OH groups. Let's look into the options. In A we have OH with second carbon and Br with the third carbon atoms, and there are 6 carbon atoms in total. So this is corresponding to this first structures, so A is present. In B we can see that OH is present with second carbon and OH is present with third carbon, and there are 6 carbon atoms in total. So this shows complete hydrolysis like this. So B is also present. In C we can see that OH is present with third carbon atom and OH is present with fourth carbon atom, which is not possible because bromine is attached to second and third carbon. So C is not present. In D we can see that OH is present with fourth carbon atom while Br is present with fifth carbon atom. So from other side we can see that Br is present with second carbon and OH is present with third carbon atom, which is corresponding to this structure. So D is also present. The only compound not present in the product is C. Question 25. Which statement about the mechanism of an SN1 reaction of a halogenoalkane is correct? Now SN1 reaction is carried out by tertiary halogenoalkanes. In the mechanism we can see that tertiary halogenoalkane is first converted into carbocation and halogen is removed. Then in second step, electrophile attaches itself with the carbocation that is formed to form product. Let's look into the option. A nucleophile is substituted by an electrophile. As we can see that both X negative and E negative are nucleophiles because they have negative charge. So therefore A is incorrect. B, one intermediate is formed from 2 reacting molecules. As we have 1 reacting molecules that forms 2 intermediates, so therefore B is also incorrect. C, the intermediate is stabilized by adjacent alkyl groups. Now we can see that this carbocation is stabilized by these 3 alkyl groups because alkyl groups are actually electron donating in nature, and due to positive inductive effect it stabilizes the carbocation that is positive. So C is correct. D, the intermediate is uncharged. As we can see that there is positive charge present on the intermediate, so therefore D is also incorrect. Correct answer is therefore C. Question 26. Structural isomerism and stereoisomerism should be considered when answering this question. Which isomer of C6H13OH gives the greatest number of different alkenes when it is dehydrated? Now, dehydration of alcohols occurs in such a way that OH is removed from one carbon atom and hydrogen atom is removed from adjacent carbon. Similarly, OH is removed from this carbon atom and hydrogen can be removed from adjacent carbon, which could be this one or which could be this one. So two products are formed. Similarly, in C, we can see that OH is removed from this carbon atom and there are three adjacent carbon atoms that contains hydrogen. So three double bonds can come. In D, we can see that OH is removed from this carbon and hydrogen is removed from this adjacent carbon. So in the first one, we can see that H is removed from this carbon and OH is removed from this carbon, and this single bond will convert into double covalent bond. As we can see that this carbon that is forming double covalent bond has similar hydrogen atoms attached to it, so therefore cis-trans isomer is not possible, so only this product is obtained. So in A we have one product. Now in B we can see that this OH is removed from this carbon and hydrogen could be removed from this carbon atom, so double bond would come on this one. As we can see that this carbon is bonded to one hydrogen atom and one ethyl group. Similarly, this carbon is attached with one hydrogen atom and one ethyl group. So two isomers are possible for this structure, one is cis and one is trans. Now for other scenario, if OH is removed from this carbon atom and hydrogen is removed from this carbon, then double bond will come between these two carbon atoms. So the product could be like this: CH3, CH2, CH2, CH, and double bond will come. Then we have CH and CH3. As we can see that one hydrogen atom is present with this carbon and one propyl group is attached. Similarly, one hydrogen atom is present with this double bonded carbon and one alkyl group is attached. So cis-trans isomers are possible. As we can see that no carbon is present that is having four different atoms or groups attached. So no optical isomer is formed, only these four cis-trans isomers are formed. So in B we have four different products. Now looking into part C, we can see that if OH is removed from this carbon and hydrogen is removed from this carbon, then simplified product would be like this. As we can see that with this carbon we have one hydrogen and one methyl group attached, and again with second carbon we have one methyl group and one ethyl group attached. So cis-trans isomers are possible. Now with the second possibility, if OH is removed from this carbon and hydrogen is removed from this carbon atom, then the product will be like this. As we can see that with both double bonded carbon atoms, similar atoms are present. With this carbon there are two hydrogen atoms, while with this carbon atom there are two ethyl groups that are similar. So therefore cis-trans will not be possible. This will be the only product. Now with the third scenario, if OH is removed from this carbon and hydrogen is removed from this carbon atom, then the product form will be like this. As we can see that the double bond is between second and third carbon atom, and there is also a methyl group attached on the third carbon atom. And similarly in this product the double bond was between second and third carbon atom and methyl group was attached with the third carbon atom. So therefore these are actually same compounds. So we will not consider this product. So we can see total number of product is one cis, one trans and one this product. So total number of different products formed are 3. Now moving towards D, OH is removed from this carbon, one hydrogen is removed from this carbon, and there will be a double bond present. As we can see that with this double bonded carbon, both hydrogen atoms are present, so cis trans is not possible. This will be the only product that is possible. So in D we only have one product that is obtained. Similarly in A we only had one product. The answer is therefore B. Question 27. Compound Q reacts with 2,4-dinitrophenyl hydrazine to give a precipitate. Compound Q does not produce a precipitate when warmed with valence solution. What could be the identity of compound Q? Now first test is with 2,4-DNPH, and we know that 2,4-DNPH gives positive result with aldehyde or ketone containing carbonyl carbons. So compound Q could be aldehyde or it could be a ketone. From second test we can see that it does not produce any precipitate when warmed with valence solution. Now we know that aldehyde does give a precipitate while ketone does not give a precipitate, so therefore compound Q must be a ketone. Let's find out the ketone. First is A is ketone, which is propanone because oxygen is attached with the second carbon. So A could be correct. B is primary alcohol, which is propanol, so B is incorrect. C is propanoic acid, again propanoic acid is incorrect, only ketone gives positive result. D is aldehyde, which is also wrong. The only correct option is A. Question 28. Structural isomerism only should be considered when answering this question. A set of isomeric compounds with the molecular formula C5H10O all react in a 1:1 ratio with an excess of HCN by nucleophilic addition. How many isomers compound are in the set? Now we can see that nucleophilic addition of HCN can occur in aldehyde and ketone on carbonyl carbon, as carbon is partial positive and oxygen is partial negative. So what happens that cyanide will attack on this partial positive carbon and this bond is broken. In the presence of HCN, the product formed is hydroxynitrile. So the compound given must be an aldehyde or ketone. Let's draw the structural isomers of C5H10O when it is an aldehyde. So we have 5 carbons, 1, 2, 3, 4. As it is an aldehyde, so therefore carbonyl carbon is the first one. The name of this compound is pentenyl as it consists of 5 carbon atoms. Now this can be rearranged in such a way that long chain is of 4 carbon atoms. Now the structural isomer will be like this. We have 4 carbon atoms in the long chain and methyl group is attached with the third carbon atom. As the numbering starts from this carbon atom, so it is 3-methyl butanol. Again we can rearrange in such a way that long chain is of 3 carbon atoms only. And with central carbon 2 methyl groups are attached. Still there are 5 carbon atoms in total. And as 2 methyl groups are attached with the second carbon, so the name is 2,2-dimethyl propanol. Also we can draw it like this, that we have 4 carbon atoms in the long chain of aldehyde and methyl group is attached to the second carbon instead of third carbon. Then the name will be 2-methyl butanol. So now we can see that we have made 4 structural isomers of aldehyde from the given formula. Let's draw the ketones of C5H10O. 5 carbon ketone can be drawn like this. We have carbonyl carbon on second carbon, so it is 2 pentanone or pentane 2-on. Similarly, the carbonyl carbon can be on third carbon. So it will become pentane 3-on or 3-pentanone. Another structural isomer of 2-pentanone can be drawn like this. We have 4 carbon atoms in the long chain, and with one of the carbon methyl group is attached. Now the name is 3-methyl pentane 2-on. So now 3 structural isomers of ketone has been drawn. So in total we have 4 plus 3, 7 structural isomers that are possible for C5H10O. The answer is therefore C. Question 29. Which pair of substances could react to give this ester given? We have 4 carbon atoms in total and oxygen is attached with this carbon. Rest are the hydrogen atoms. Now we know that ester is formed from alcohol and carboxylic acid functional group. So if we break this ester from this carbon-oxygen bond, what will happen that the part containing carbonyl carbon will become acid. So it is propanoic acid. As it contains 3 carbon atoms, and second portion will come from alcohol. So it is 1 carbon alcohol, so it is CH3OH. So the name is methanol. Now the ester that is formed from these two is called methyl propanoate. The answer is therefore C. As we can see, methanol and propanoic acid are present. Question 30, an ester is shown. This is the structure of ester. We can see this one is ketone functional group, this is ether functional group, and this is the ester functional group. What is the structure of the carboxylic acid that would be obtained by acid hydrolysis of this ester linkage? Now we know that in acid hydrolysis, in the presence of water and H+, ester is converted back into carboxylic acid and alcohol. Let's see which carboxylic acid is formed from this ester. Upon acid hydrolysis, this bond will break, which is carbon-oxygen bond, and the portion consisting of carbonyl carbon will form the acid and the other portion will become alcohol. So the alcohol is like this. OH, while the second portion that forms acid would be like this. So as we have 1 carbon atom in this carboxylic acid, so it is methanoic acid. The answer is therefore A. Question 31. Which deductions about bismuth 20983 atom are correct? Number 1, it has 83 electrons. As we can see, the atomic number is 83 and there is no charge. So there must be 83 electrons as there are 83 protons. Number 2, it has 126 nucleons. As we can see that the nucleon number is 209. So therefore 2 is wrong. Number 3, it has 83 neutrons. Now neutrons can be obtained by subtracting nucleon number from atomic number. So it will be 209 minus 83, which is equal to 126. So 3 is also incorrect. As only option 1 is correct, the answer is therefore D. Question 32. Which statements are correct when referring to the two common isotopes of chlorine? Now about chlorine, we know that the atomic number is 17 and there are two isotopes. One is chlorine 35 and second is chlorine 37. Number 1, the isotopes have different masses. As we can see that the nucleon number is different, so the atomic mass is also different. This is true. Number 2, the isotopes have different number of nucleons. One is having 35 nucleons, second is having 37 nucleons. This is also true. Number 3, the isotopes have the same chemical reactions, as chemical reaction depend on the number of electrons, not on the number of neutrons, so therefore the electrons are same as it is the same element, so this is also correct. As all three are correct, the answer is therefore A. Question 33. For which enthalpy changes is the value of delta H always negative? Negative enthalpy change means exothermic chemical reaction as energy is released. First one is combustion. As we know that energy is always released in combustion, so this is exothermic reaction and delta H will be negative. Second is hydration. Now enthalpy of hydration is the energy released when attractions are set up between ions and water molecules. The ions can be positive or negative. So when forces of attraction are developed between ions and water molecules, what happens that energy is released. So it is also exothermic. Third is the enthalpy of solution. Now enthalpy of solution could be positive or could be negative. It depends on the type of salt that is dissolved in water. For example, if we have calcium chloride, the enthalpy of solution is negative 81.3 kilojoules per mole. So it is exothermic in nature. While if ammonium nitrate is dissolved in water, what happens that the enthalpy change is positive. So it is plus 25.7 kilojoules per mole. So it could be positive or negative, so therefore it is not always negative. As option 1 and 2 are correct, the answer is therefore B. Question 34. The diagram shows the Boltzmann distribution of molecular energies in 1 mole of a gas at two temperatures T1 and T2. One curve is for T1, second curve is for T2. Which statements are correct? Number 1, the shaded area represents the proportion of molecules with energies between E1 and E2 at temperature T2. As we can see that this is the graph for T2 and this is the energy change that is given. Now this is the proportion of molecule that represents this much energy. So this is true statement. 2. No particles have zero energy at either temperature. This is true because we have gases and gases particles do not have zero energy. 3. T2 is a higher temperature than T1. As we can see in the diagram that in T2, more number of molecules have higher molecular energy as compared to T1. So therefore the temperature T2 is higher. As all three options are correct, the answer is A. Question 35. Which statements about sodium chloride are correct? 1. It is a product of the reaction between chlorine and cold aqueous sodium hydroxide. Now we can write the reaction. We have chlorine and cold aqueous sodium hydroxide. The product formed will be sodium chloride, NaClO and H2O. So as sodium chloride is formed, so 1 is correct. 2. It is a product of reaction between chlorine and hot aqueous sodium hydroxide. Again we can write the chemical equation for this one. We have chlorine and hot aqueous sodium hydroxide. Now the product is sodium chloride, sodium chlorate, which is NaClO3 and H2O. As we can see that sodium chloride is formed, so 2 is also correct. 3. It is a product of the reaction between chlorine and aqueous sodium bromide. Now we can see that chlorine is above in reactivity series as compared to bromine. So now chlorine can displace bromine to form sodium chloride and Br2. So 3 is also correct, as all options are correct, so the answer is A. Question 36. Which gases will dissolve in water causing a lowering of the pH? Such gases should be acidic gases. First one is ammonia. Now ammonia is basic in nature as it dissolves in water to form ammonium hydroxide, which increases the pH. So 1 is incorrect. 2 is sulfur dioxide. Now sulfur dioxide is acidic gas as it dissolves in water to form H2SO3. So 2 is correct. 3 is nitrogen dioxide. Again, this is also acidic gas as it is non-metal oxide and it dissolves in water to form nitric acid. So it will lower the pH. As option 2 and 3 are correct, the answer is therefore C. Question 37. Which compounds have optical isomers? Now those compounds have optical isomers in which such a carbon is present which is attached with 4 different elements or groups. Let's look into the options. In 1 we can see that this carbon is attached with hydrogen OH, this whole group and this C double bond OH. So this is chiral carbon. Again we can see that the second carbon, this one is also chiral as it is attached with 4 different groups. This one is also chiral. This one is not chiral because it is attached to 2 hydrogen atoms that are same. This is also not chiral because it is attached with oxygen with a double bond. So option 1 is correct. 2, we can see that this carbon is attached with one of the hydrogen atoms. So it is chiral. This carbon is attached to 2 hydrogen atoms, so it is not chiral. This is attached to 2 hydrogen atoms. Again, this is not chiral. This is attached with 1 hydrogen atoms and 3 other groups. One is this one is this one is this one. So this is chiral. Similarly, we can see that this carbon is also attached with 1 hydrogen atom and it has 4 different groups attached. So this is also chiral. Looking at this carbon, we can see that 2 similar groups are attached. Both are methyl groups, so this is not chiral. Again, CH3 is not chiral as it has same hydrogen atoms attached. So we can see there are 3 chiral centers in 2, so it can show optical isomers. Moving towards third one, we have this carbon which is double bonded, so it does not show optical isomer. This carbon is also double bonded. This is also making a double bond. This is also making a double bond. So none of the carbon atom is chiral, so therefore 3 will not show any optical isomer. As option 1 and 2 are correct, so therefore answer is B. Question 38. Bromine reacts with ethene in an addition reaction. Which statement about this reaction are correct? Now bromine can add itself in alkene. For example, we have ethene to form 1,2-dibromoethane. 1. It is the basis of a test for unsaturation in alkenes. This is true because bromine is decolorized from reddish brown to colorless as it is added in alkene. 2. It leads to an increase in each of the HCH bond angles. As we can see that in CH2 double bond CH2 the bond angles were 120 degrees as there were 3 bonds around the central carbon, so it is 120 degrees. But now in CH2Br we can see that carbon is making 4 single bonds. So now the bond angle has decreased to 109.5. So this statement is wrong. 3. A nucleophile attacks the carbon double bond in ethene. Now addition in ethene is actually electrophilic addition where these electrons they attack partial positive bromine and partial negative bromine is then separated. So this is not a nucleophile attack, so therefore 3 is incorrect. As only option 1 is correct, so therefore answer is D. Question 39. An unknown organic compound Z reacts with sodium to give a combustible gas as one product. Z does not give a yellow precipitate with alkaline aqueous iodine. What is the possible identity of Z? First one is ethanoic acid. Ethanoic acid consists of 2 carbon atoms. It can react with sodium metal in an acid-metal reaction to form salt, which is sodium salt of carboxylic acid, along with hydrogen gas, which is combustible. Also, we can see that carboxylic acid does not give yellow precipitate with alkaline aqueous iodine, so 1 is true. Second is pentane 3-ol. In pentane we have 5 carbon atoms, and on third carbon we have alcohol functional group that is attached. Now, as we know that alcohol can react with sodium to form sodium alkoxide, along with the formation of hydrogen gas. Also, we can see that we have ethyl functional group with this carbon on one side and ethyl functional group on second side, so therefore it will not give yellow precipitate with alkaline aqueous iodine. So 2 is also true. 3 is propane 1-ol. Now in propane 1-ol, alcohol is attached on the first carbon while we have 3 carbon atoms in total. Again, it will react with sodium to form sodium alkoxide, along with the formation of hydrogen gas. Again, we can see that with this carbon which is attached with OH, ethyl group is attached, so therefore it will not give yellow precipitate with alkaline aqueous iodine. So 3 is also correct. As all 3 options are correct, the answer is therefore A. Question 40. An organic molecule X has the molecular formula of C5H10O2. Its infrared spectrum has a strong peak at 1250 per centimeter, strong peak at 1720 per centimeter, but no strong peak above 3100 per centimeter. What could X be? Now from data booklet we know that the peak at 1250 centimeter is because of carbon-oxygen bond, which is due to the presence of alcohol or esters or ethers. Second strong peak is at 1720 per centimeter. Now we know that from data booklet this is because of carbonyl carbon, and the functional group present could be aldehyde, ketones, carboxylic acids, and esters. Then we can see that no strong peak is observed above 3100 per centimeter. Now we know that from 3200 to 3600 per centimeter a strong peak is observed for alcohol. So therefore alcohol is absent. Let's look into the options. One is ethyl propanoate, so we can draw it like this. As we can see that carbonyl carbon is present, so this peak is present for ethyl propanoate. Carbon oxygen bond is present, so 1250 per centimeter peak is also present. As there is no OH group, so third peak is absent. So 1 is true. Second is methyl butanoate. Again, this is an ester. The structure will be like this. As we have butanoate and methyl group is attached. Again, we have carbonyl carbon, carbon oxygen bond, and there is no alcohol, so therefore this is also true. Third is 1-hydroxy pentane 3-on. So we have 5 carbon in total as it is pentane. On first carbon we have hydroxy, which is OH, and on third carbon we have ketone, so this is carbonyl carbon. As we can see that OH group is present, so it must give a strong peak above 3100 per centimeter, and the peak should come in this region. So 3 is incorrect. As option 1 and 2 are correct, the answer is therefore B. Thanks for watching. A like, comment and subscribe will be highly appreciated. You can find related videos in playlists. Stay happy and enjoy learning.